All right, hello, Mr. Ellison here. This is a video walkthrough of pre-calculus assignment PC 5.16, which is in January of 2021. This is what it looks like. So if you click on that PDF, that worksheet, this is the worksheet, and it says to find the area of these triangles. And so when you do this, you're going to have to use different methods. You might have to use different methods for different triangles because they all kind of have different things going on. So we're going to start. We are going to start with number 2. So we're going to start with this one right here. Alrighty, except I'm going to go over where I get more space. So we're going to go over here. Does that stay on there? It does. Look at that. How about that? I hope this is recording. We'll see. It looks like it should be. Okay, so we have this triangle, and let's just one way when you're confronted with something that you're not sure how to do it. One of the things you can do is just start writing stuff down. So what I'm going to do actually is I'm going to start by labeling this. And that means that I've got an angle A and the opposite side is right there. So I'll put that. And I've got an angle B and the opposite side is right there. Well, I don't really like that shadow thing. That's a big pain. But I guess I don't know how to turn that off, so whatever. And then this is going to be the C side, right? And we're supposed to find the area of this triangle. So we have an angle and 2 sides. So the question is, well, first of all, what's the formula for the area of a triangle? The area of a triangle is 1/2 times the base times the height, right? And so one of the things that you got to keep in mind is that the height could be, you could make the height basically has to be at right angles from the base. So you could take the height right there, or you could take the height right here, or you could even extend this line along here and take the height right here. Whichever one you want, as long as the height you choose is at a right angle with the base that you choose. So I'm going to erase those because I will tell you which one I am going to choose. And it's going to, the interior ones are just going to be easier. There's no way around that. Okay. So I'm going to leave those labels in blue, and then I'm going to switch colors to something different. How about green? Okay. Now I'm green, and what I'm going to do is I'm going to make a perpendicular right here, like this. All right. Now we know that this is 90 in both directions, right? And so what I'm going to do is I'm going to work with this triangle to start with. And in fact, that's the only triangle I need to work with, because what am I looking for? I'm looking for this height right there, right? Because if I can do that height, I already know this base. So again, the base doesn't have to be the bottom. It just has to be the thing that's perpendicular to the height. So that's going to be my base. My base is going to be 11. And now all I have to do is find that height. And that's pretty easy, isn't it? Because I know angle C. So I've got angle C, and it equals 51 degrees. And if this angle right there is 51 degrees, and it's a right triangle, then I know the hypotenuse equals 4.8, right? 4.8 meters. They do give us the units, so we're going to want to keep the units. And what am I trying to find? I'm trying to find the opposite side. The adjacent side is the one touching the angle. The opposite side is the one the angle opens up toward. So the opposite side is the one I'm trying to find, right? So now we know an angle, we know the hypotenuse, we're looking for the opposite side. So now we'll just go back to our happy little trig saying, so katoa, which reminds us that the sine of an angle is the opposite over the hypotenuse. The cosine of an angle is the adjacent leg over the hypotenuse, and the tangent of an angle is the opposite over the adjacent, right? So we know the hypotenuse, we know an angle, and we want to find the opposite, so sine is what we're going to do. So we're going to say the sine of 51 degrees, that's the angle, right, equals the opposite, that's what we don't know, over the hypotenuse, which is 4.8. Now we'll multiply both sides by 4.8, and we'll end up, they'll cancel out on the other side, and we'll get 4.8 times the sine of 51 degrees equals x. So then we'll have our x. Somebody borrowed my calculator. There it is, right there. Okay. So now we're going to do 4.8 times the sine of 51 degrees equals x. And this says that x is 3.7. 3.7 equals x. 3.7 meters, right? Is that reasonable? Yes, if we just look at the triangle and we see the hypotenuse is 4.8, it's very reasonable that the x where I've drawn it, that perpendicular thing that I drew is 3.7. So that passes the sort of reasonability test too. So now we're going to go over here and back to our area formula. Area equals 1/2 times the base times the height. So the area equals 1/2 times, and our base is going to be that 11 meter thing. It doesn't matter that it's up there on the side. What matters is that the height is perpendicular to the base is 3.7. And so now we're just going to put that in the old calculator. 0.5 times 11 times 3.7 equals, the area is 20 I'll call it 4. It's 20.35, 20.4 meters. Really significant digits, we should just call that 20 and be done with it. But this is a math class, not a science class, and they didn't ask us about significant digits. So let's go back and see if we got it right. It's number 2. 20.5. Is that what we got? We got 20.4. What? That's all right. It's close enough. That means our method was correct. All right. So let's look at a couple others because they're gonna. And I'm not going to do the whole math for all of them, but I do want to kind of just make some observations for you to get you going. So this again on number 1, that's got an angle and a side and an angle. So you can drop a perpendicular right there. You can see that I'm back on the thing with the thick fat lines. But anyway, so you can see that we can draw that perpendicular and find the height the same way there. Here we can do the same thing, right? Here, now we're on number 5. Number 5, you know 3 sides and you don't know any angles. So what are you going to do there? Well, if you know 3 sides and you don't know any angles, you need to find an angle basically. Because look, if you just drop a perpendicular right there, that doesn't help you. I mean, you know that's a 90-degree angle, but that's not doing anything for you at all. Although actually, nope, it isn't. If you knew how far this piece was, then you could use a trig function, but you don't, so you can't. So what we're going to have to do there is, and I'm just going to give you the steps. We already had a worksheet on the law of sines. So on this one, for instance, we've done law of sines and cosines, and we have to use those. So for both of these, the first thing you have to do is find one angle. And you can use the law of cosines to find an angle. And just to refresh your memory, the law of cosines is c squared equals a squared plus b squared minus 2ab cosine of c, which is the angle, that's the angle that's opposite this side, right? So there's that, and I have to rush. Someone came into my classroom, and now I have to finish up everything else. Okay, so for this one, you've got two angles, which means you automatically can figure out that angle easy. And once you have that angle and that side, oh, we're not trying to do that. Hang on. So, well, yeah, you could figure out that angle and that side, right? And then you've got all three angles, and you've got a side. So, well, let's see. One thing you could do. Anyway, you got to figure out a combination of the law of sines and the law of cosines, and you can figure this out. And I'm sorry that that's going to have to be the end of this video, but I got to go. Make sure you email me, though, if you have questions about this one, all right? Bye.